Okay, let's talk about continuity. We have an informal definition and a formal definition. So informally, a function is continuous where it can be drawn without needing to lift your pencil. That's continuous. Formally, a function is continuous where the limit and the function value are the same. So I can take a limit and f of that limit and it's the same number. So here's that formal definition written out. So if the limit from the left equals the limit from the right, which equals the function value. So if you can take all three of those and they're the same, then your function is continuous at that point. Now we have three types of discontinuities. We have holes in our graph, which we saw up here in our example. We have vertical asymptotes, which we also have in our example right here. Or we have jumps, which was right here at 5, where the graph jumps. Those are your three types of discontinuity. We do have a fourth type, which is an oscillating discontinuity, but it very rarely happens. One example is sine of 1 over x, which you can look at your calculator as you get closer and closer to x equals 0. It does some weird stuff. So we won't talk about that one a whole lot right now. So we're going to look at this one. Here's the example graph we had here. We want to list the x values of our discontinuities. So remember, we have three types. We have holes, vertical asymptotes, and jumps. So if I look at this graph, where are my holes? So I have a hole at x equals -1, right there. I have a hole at x equals 2. So those are my holes. I have a vertical asymptote at x equals 3. And then I have a jump at x equals 5. Those are my discontinuities. Now we can label discontinuities as removable or non-removable. A removable discontinuity happens when the function has a limit, aka holes. Non-removable discontinuities are when the limit does not exist. So we saw a couple of those up here when we have D and E on our limit. Those are non-removable discontinuities, aka jumps, vertical asymptotes. So if we look at this, which of those discontinuities from example 13 are removable? Only the holes, so that would be x equals -1 and 2. 3 and 5 are not removable because they're asymptotes and jumps. I think I'm going to cut off this video right there. And in the next video, we'll talk about direct substitution.